Hello and welcome to my video, lesson 2.2 on trigonometric ratios, part 2. So here we're looking at, first of all, looking at the cast rule. So this is where we look at our unit circle and we see that cos is positive here. All of our trigonometric ratios are positive here. Sine is positive here and tan is positive here. This is super important to remember. If you don't, review that, memorize that, it's important. Okay, and from our last video, we have these two special triangles to remember, where we have the two 45-degree angles will mean that we have the following ratios with 2, root 2, root 2. And then at the other triangle, we have the 1, right, 2, 3 rule, where those are the three numbers to remember, and it's got three angles, 90, 60, and 30, or 60 and 30 is the part that you really have to remember. And so with these two triangles, we have these ratios, and they're special ratios because we can actually remember them. Even if they are irrational, they have the roots, they're still very, very useful, and we like to use them whenever we can, because exact values are better than decimal values, and you will be asked exact values on tests, for example. So inverse trig functions. So last video we looked at, and last half topic, we looked at going from the from two sides to getting the angle. Now we're looking at going from the angle and a side to getting to the other side. Is that the way around it is? Hold on. Now I have confused myself. It should be inverse trig function. So this is going to be regular. Sorry, last video we looked at it like this. How about I mix it up a little bit? So this video we are going to look at examples where we have two sides. So let's make this one 5 and this one 10, okay, where we have two sides and you're looking for the angle. Okay, so you have to be able to do both, but this is the inverse trig function. Okay, so here we are going to use the SOHCAHTOA rules. And you're going to look at where the angle is, and you're going to say, hey, this side is opposite. This side is opposite. And this side is the hypotenuse. Okay, so if we have the hypotenuse and the opposite, we're going to be using our sine function. So sine of our angle equals opposite over hypotenuse. And in this case, 5 over 10, which is great, because we can now relate it to one of our special triangles. Okay, so what we're going to do is we're going to go theta equals sine -1 of 5 over 10, and we can actually get what this is, or another way to simplify it is 1 over 2. And if you can simplify it to 1 over 2, that means we have 1 over 2. Right? And so if you are using those two values, you can imagine that if this is the opposite, right, and this is the hypotenuse, well, which side is opposite of the 1? It might not be 100% clear. Oops, there you go. It might not be 100% clear, but opposite side to the 1 is the 30, right? So if that's the case, our theta is 30 degrees. Okay, so it's just all about relating the triangles that you have, whatever are given in the questions, to one of these two special triangles, and then using the ratios to help you out. So whether that be 1 over 2, or comparing the 5 over 10 to the 1 over 2, or maybe you have a root 3 situation. So maybe you have 6 and 3. So both of those are multiplied by root 3. So you could work with that. So like if you had, for example, cos -1, which would be adjacent over hypotenuse, right? Okay, and if you had 3/6, that is the same ratio, right, as divided by 3. No, that's not helpful. No, that's not the same ratio. Hold on. Root 3/2. So if you multiply by 3, no, you have to multiply by root 3. There you go. I'm like, why is there something going on? Okay. Anyway, so if you could have some funky relations going on. So you could have like a side length of this, and then it would work. But anyways, basically you're trying to compare your ratios to one of the special triangles, and then going for the different angle, depending on which one fits at any given moment. All right, I hope this video helps you understand trig functions a little bit better, especially with the exact values that we're looking for. Like in this case, we're using the special triangle to get angle 30. Hope this video helps, and good luck.